Hello students. Today we are going to solve an example using the false position method. So we will take a equation and we will try to find out its root using the false position method. So here our example is find the root of equation cos x minus 3x plus 1 is equal to 0 correct to 3 decimal positions given that the root of the equation lies in interval 0, 1. So we have been given that our root lies between 0 and 1 and we have to find that root of this equation. Now the first thing is that false position method is used to solve the set of nonlinear equations. But yes, of course, it is fastest as compared to the bisection method as its conversion rate is high. So here the formula to evaluate the x3 value in the false position method is x3 is equal to x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. As we have already derived this formula in the previous lecture, so here in this lecture we are directly using the formula. So as we are given here with the 2 points or the interval 0 and 1. So in our iteration first, we will start with x1 is equal to 0 and x2 is equal to 1. So then we will first of all evaluate the value of x1 and evaluate the value of f of x2. F of x1 and f of x2 because we are using these values to evaluate the value of x3. So f of x1 will be equal to cos of x, where x here is 0, so we are taking cos of 0 minus 3 of 0 plus 1, which will be equivalent to 2 because cos 0 is equal to 1 minus 3 multiplied by 0, that will be equal to 0 plus 1, that will be equal to 2. Then what we are doing here is we are just simply putting these values in the equation and getting f of x function. Similarly for f of x2, which will be equal to, because x2 here we have 1, so f of x2 will be equal to cos of 1 minus 3 of 1 plus 1, that will be equal to minus 1.0001. If you will calculate this, it will be equivalent to minus 1.0001 because cos 1 is equivalent to 0.99 something. So when you will evaluate it, it will come to minus 1.0001. Then what you have to do, you have to evaluate the value of x3. You have to get the value of x3. As we know, the formula for the x3 is x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. So we are simply putting the values of x and f of x in this equation. We get the value. Here x1 is equal to 0. F of x2 is equal to minus 1.001. x2 is equal to 1 and f of x2 is equal to minus 1.00. So now we will evaluate it. When we are evaluating it, it will be equal to 0.6666. Now we have to check. The way we were checking in the bisection method, similarly here also we have to check whether f of x1 multiplied by f of x3 will be greater than 0 or less than 0. So first we have to check. See now, here f of x3 first we have to evaluate. When we are evaluating f of x3 will be equivalent to 0.6666, which we got in the from the previous step, the value of f of x3. Now we are taking the value of f of x3 as our given equation is cos of x minus 3 of x plus 1. So here it will be equal to cos of 0.6666 minus 3 multiplied by 0.6666 plus 1. When we will evaluate this, it will be equivalent to 0.0001. Then we have to check whether f of x1 multiplied by f of x3 is greater than 0. If that is the case, then we have to replace x1 by x3. when we see the value of f of x1 and f of x3, if you see the value of f of x1 is positive and the value of f of x3 is also positive. Therefore, when we multiply positive with a positive, it will be always greater than 0. So therefore, we will replace x1 by x3. So we are replacing value of x1 by this new value x3. So our new search interval will be 0.6666 and 1.0. Similarly, for our next iteration, we have to follow the same steps. Now, we will take 0.6666 as x1 and x2 as 1.0. So when we will solve it for this, as our x1 is now x3, so we have already calculated the value of x3 here, so which is becoming x1 in the next iteration. So we will directly take the value from here. So we are taking f of 0.6666 as 0.0001. Similarly, we have to evaluate for f of x2, which will be equivalent to minus 1.0001. Again, then we have to check, or we have to calculate the value of x3. x3 is equivalent to, in the false position method, x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. So we are just putting the values of x1 f of x2 in this equation, then we get the value 0.6665. So again, then we have to calculate f of x3. When we calculate the f of x3, it will be equivalent to cos of x3, which is 0.6665 minus 3 multiplied by 0.6665 plus 1, which will be equivalent to 0.0004. So again, we have to check whether f of x1 multiplied by f of x3 is greater than 0 or not. In our case, it is coming as greater than 0 because the value of f of x1 is positive and the value of f of x3 is positive. Both of these are of the same sign, so it is greater than 0. Therefore, we again replace x1 by x3. When we are replacing x1 by x3, our new interval becomes 0.6665 and 1.0. So similarly, when you will calculate this for the next iteration, you will see there is no change in the value of an x3 up to 3 significant digits, because in the next iteration also you will see, if you will solve it, you will see that it will be same as 0.666 for the 3 significant digits. Therefore, in 3 iterations, when we find that there is no change up to 3 decimal places, so we will stop here and we will say that x is equal to 0.666 is the solution, or we can say is the root of the given equation. So when you are calculating the values, I recommend that you should have this scientific calculator very handy so that you can calculate your functions and you can calculate your iterations through the scientific calculators. So it will be very good if you will keep this thing handy so that you can evaluate your values on the scientific calculators. So thank you for today's lecture.